Okay, welcome back to your grade 8 Reachback answer video. Hopefully you have written down and shown all your work and you've taken a picture of your work and sent it to your teacher. So as we go through these questions, please make sure you have your work in front of you and either use a highlighter or a pen and make notes of anything you did wrong or should have done differently to get the correct answer. Start with question 1, which is an addition question coming from your grade 7 curriculum. And when you add fractions, remember that the reason why we find a common denominator is because these are not the same size pieces. If we think about what 3/5 looks like, 1, 2, 3, 5 parts, 1, 2, and 3. And if we think about what 5/6 looks like, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The reason why we can't add them together is because this size piece is a fifth, and this size piece is a sixth. And if you said, how many total pieces do you have? You can't add them all up because they're not the same size. So what we end up doing is we make common denominators, or we change the size of the pieces so they're all the same. So we make what's called equivalent fractions. So if we think about why we do this right here, now what we're going to use as a common denominator is 30. And the reason why we use 30, of course, is because it's the first multiple that 5 and 6 share. So if I was to write these out, that would be all the multiples of 5, or up to at least 35. Those would be all the multiples of 6, up to 6 times 7. And if we think about what's the first one they share, 30 is a multiple they both share. So what that means is I can actually create an equivalent fraction that has a denominator of 30 by creating this equivalent fraction. So if we think about 3/5, so if I was to draw 3/5, these are fifths. This would be 1/5, 2/5, and 3/5. Actually, you know what I'm going to do? I'm going to use my highlighter instead. So 1/5, 2/5, 3/5. This is going to be a little bit easier to see. Okay, so there's 3/5. And if I was to say that's 3/5 of a chocolate bar or 3/5 of pizza or whatever, we kind of understand that. But if I was to cut these into 6 slices each, so I'm going to go this way here. I'm going to cut them this way first, and then this way here, and then this way here. So now if we were to count these up, I'd have 1, 2, 3, 4, 5, and there's 6 rows of 5. There'd be 30 pieces altogether there. And if I go back and erase those blue dots, of the 30 pieces that exist, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 are shaded yellow. So 3/5, which was the yellow originally, and 18/30, which it is now when I cut it into 30 parts, are the same amount of pizza or the same amount of chocolate or whatever you want to think about. So they're called equivalent fractions. So we drop an 18 here, and 3/5 is the equivalent to 18/30. And 5/6, I'll do the work down here, is equivalent to, and we're going to make an equivalent fraction, and we do so by multiplying both numerator and denominator by a common multiple, is equal to 25/30. So now that we have them in the same size pieces, we can say, well, how many 30ths do we have altogether? We have 18/30 plus 35/30, which is a total of 53/30. Now we call this an improper fraction, and as a mixed fraction, that would be 1 and 23/30. And that is your final answer, 1 and 23/30. I made a mistake, didn't I? Oops, it's supposed to be 25, not 35. Oops. There should be 43. Oops. And that should be 1 and 13/30. Not 40. So I made a mistake by 10. My apologies. See? Even the smartest, most brilliant math teachers in the world make mistakes. It's not me, but I'm sure that people like that do make mistakes. Question 2, we have the same type of question except it's subtraction. So this time, I'm going to write the multiples of 8 and 10 out. And we got 8, and we got 16, and we got 24. And we got 32, and we got 40, and we got 48. And I'll stop there. And we got 10, and we got 20, and we got 30, and we got, 40. So the first multiple they share is 40. Now, if I used 80, that's okay because that is a common multiple. But the LCM, or the lowest common multiple, is always the easiest denominator to use. So we're going to choose to use 40 here. We're then going to make our equivalent fractions. So 1/8 is equal to how many 40ths? Well, we multiply both by 5, and I get 5 40ths up here. Take away 1/10, so 1/10 is equal to how many 40ths? That's 4 40ths. So if I have 5/40, take away 1/40, or 4/40, my answer is 1/40 is remaining. That's your answer, 1/40. Question 3, we get into grade 8, which is multiplication, and this particular fraction question is a mixed fraction multiplied by a whole number. So if we have 1 2/5, if I was to draw this and say this is 1 chocolate bar and 2/5 of a chocolate bar. So there's 1 2/5 of a chocolate bar. So we have a full chocolate bar and we have 2/5 of one. And if I was to take this, I'm just going to group this together. And I'm going to go infinite cloner. And if I was to multiply it by 3, 1, 2, 3, then I could clearly see by taking 1 2/5 and multiplying it by 3, I have 3 whole pizzas, and I have 6/5 here, right? 2/5 and 2/5 and 2/5, which would be 6/5. And 3 and 6/5 is the same thing as 4 because, and 1/5, because this is equal to 1 and 1/5, right? So we'd have 4 and 1/5 altogether. And that's if you solve this using drawing, but luckily there's an easier way than drawing this. And that way is to multiply a mixed fraction by a whole number. So we're going to change this to an improper fraction, which would be 7/5, multiplied by 3, which we thought of as being 3 over 1. And when I multiply the numerators and I multiply the denominators, I get 21 over 5, which is equal to the same answer I got before, which is 3 and 1/5. Okay, so your final answer is 3 and 1/5. Question 14 says multiply 3/4 by 16 over 21. Now, if you did multiply 16 by 3, you got 48. And if you multiplied 4 by 21, you get 84. And then you're like, okay, I'm going to divide by 2 to reduce it to lowest terms. I get me 24 over 42. Well, you divide by 2 again. And you get 12 over 21. You're like, I think I'm done. Oh, but you'd be wrong, because both are divisible by 3. Remember, 1 plus 2 is 3, which is divisible by 3, and 2 plus 1 is 3. So that would give me 4 over 7, which is my answer in lowest terms, and that's your final answer. However, you could have, take my eraser here and erase that whole thing there. I could have cross-reduced. I could have said, well, 16 over 4 reduces to 4 over 1. And 3 over 21, both are divisible by 3, gives me 1 over 7. And when I multiply this, and when I multiply this, I get my same answer of 4 over 7. So if you cross-reduce, you got 4 over 7. If you multiplied and reduced by divisible multiples, or divisible factors, excuse me, you would get 4 over 7 as well. Question 5, we have the division of a mixed fraction by a whole number. Same process. We can change those improper fractions to, those mixed to improper, and we can divide by 3, which of course is 3 over 1. Now there are two options. You could use a common denominator, which we learned before, but there's a much more efficient way. We can keep the first fraction, change the multiplication by the reciprocal of the second, and by doing it this way, we get the same answer as if we divided it and found a common denominator, which would be 13 over 24, which is your final answer. Question 6, we start getting into basic, I think this is actually grade 5 maybe grade 4, subtraction of decimal numbers. So whenever we add or subtract decimal numbers, the secret is to line up your decimals. 8 subtract 9, you can't do it, so you borrow. 18 subtract 9 is 9. 4 subtract 7, you can't do it, so you borrow. 14 subtract 7 is 7, and 0 subtract 0 is 0, so you end up with 0.79 as your final answer. Question 3, the addition of 3 decimals. So again, we're going to line up our decimals. Yep, that's right. 5, 12, carrier 1, 11, carrier 1, 5, and 6. Drop your decimal down, you get 6.125. Verify it with a calculator, make sure I didn't make any silly mistakes, which I tend to do. 4.3 plus 1.76 plus 0.065 equals 6.125. Yay for me. Question 8 is the product of a decimal number and a whole number. So what we ended up actually saying to do in the curriculum is you said you estimate. So if I said this is approximately 5 times 7, then I would say it's an estimation would be roughly 35, would be a good estimation for what 4.5 times 7 should be. And then what we do is we drop our decimal and simply multiply it out. 7 times 5 is 35, carry your 3. 7 times 4 is 28, plus 3 is 31. And then since I have 315 and my estimation was 35, the place I have to put my decimal is there, and I end up with the answer of 31.5 as my final answer. Double check with the calculator. 4.5 multiplied by 7 is 31.5. Question 9, we have the division of a decimal by this. So what we're going to do is we're going to take our 72.8 and we're going to divide it by 7. And what we do is we say, how many 7s are there in 7? There's 1. So I'm going to write that up there. That becomes 7 times 1 is 7. I subtract and get 0. Bring down my 2. How many 7s are there in 2? There are 0 of them. That makes 0. Put a 2 and bring down your 8. The decimal floats to the top. How many 7s in 28? There are 4. And that means it is 10.4, and we have a remainder 0, so that's a terminating decimal answer, and we get 10.4. Take our calculator, make sure we have it right. 72.8 divided by 7 is 10.4, so we're right again. And finally, your last answer is what is the square root of 60? So remember how we did this before. We put the square root of 49 is 7. The square root of 64 is 8. So the square root of 60 is roughly here, which would be about 7.8-ish, maybe, or 7.7 or 7.9. Take your calculator, ask it, what is it? Oh, and you said square root. That says 7.7, so we estimated it at 7.8, but actually it should have been a little bit more this way. 7.7 is your answer. So hopefully you took that in. It's only 11 minutes and 45 seconds of video, so if you've made any mistakes, make sure you make a note of it because tomorrow's video is going to be a similar type reachback, and you can use this as a guide to help you be more successful with Wednesday's reachback. Thanks for watching. Remember, stay safe, wash your hands, maintain social distancing, and as always, don't let your boomer parents drive you crazy.